Hello everyone. Our project is using news to predict stock movement. As we all know, the stock market is very sensitive with the news. So our job is to make predictions about stock movement with a confidence level based on the news. First, we're going to give an overview of the data. Then we'll introduce our data preprocessing. In the third part, we will discuss about 3 models we used, including their structures and results. Finally, we will compare the 3 different models based on their performance. Let's first take a look at the data. We got a news data from Thomson Reuters, who provided a CSV file with 35 features, including providers of the news, relevance with the stock, word count, positive, negative, or neutral sentiment, etc. The data is from 2007 to present and contains around 9.3 million of entries. Here's a picture after we read in the data in Pandas data frame. It contains features such as headline, urgency, subjects, sentiment, and volume counts, which can tell us the basic information about the news. The market data was obtained from a company named Intrinio. It contains 3,511 stocks in US stock market with 16 features including open price, close price, trading volume, calculated returns, etc. The data is from 2007 to present and contains around 4 million entries. Here is the data frame for the market data. To evaluate our performance, we need to predict assigned confidence value, Y, which is multiplied by the market-adjusted return of a given asset over a 10 days window. If we expect a stock to have a large positive return compared to the broad market over the next 10 days, we might assign it a large positive confidence value, close to +1. If we expect a stock to have a large negative return, we will assign it a negative confidence value near -1. If we are unsure about this, we will assign it a value near 0. For each day in the evaluation period, our output will be calculated by the formula above, where R is the 10-day market-adjusted leading return for day T for instrument I, and U is a 0 or 1 Boolean variable that controls whether a particular asset is included in the scoring on a particular day. Our final score is calculated as the mean divided by the standard deviation of our daily X values. We use 3 models for this task. The first model is deep neural network. The second model is long and short-term memory, and the last one is light GBM. The test data is from the first day of 2017 to July 31st of 2018. Our expected outcome is to have a score greater than 0.6. Now let's move on to the data preprocessing. As we all know, in 2008, there was a huge financial crisis in the world. Now we assume that the financial crisis will not happen in the next 6 months. So we decided just cut off the data before 2009 for our prediction. Also, if a specific stock increases or decreases more than 50% in one trading day, we will classify it as an outlier. In our outlier analysis, 21 rows were removed from the dataset. Next, we analyzed the missing value. We found out that most of the missing data is only in the column of market-adjusted return. So we just fill in the empty entries with the value from the column of the raw value returns in the same row, since these two columns are quite similar. The news data also has some numerical entries. We sorted them from smallest to largest and removed the first and last two percentiles. Here is a heat map of the correlation of features for the news data. This is the correlation of features for the market data. And then we combine the news data and market data to get a correlation of features from both datasets. Dark blue represents strong positive correlation, while dark red represents strong negative correlation. We only care about the value which are circled by the red rectangles. These are related to our final prediction. We can see that none of these features have a very strong correlation with our predictor. We tried deep neural network as the first model. We split the training set and data set in a ratio of 3:1. Then we encoded the categorical data and scaled the numerical data. We also used early stopping to prevent overfitting. We tried L2 regularization, but the outcome is not very good. The architecture of DNN is like this. For numerical data, we use two hidden layers with 128 and 64 nodes. For categorical data, which is the name of the asset code, we use a 32 nodes hidden layer. And then we concatenate them together with one more layer with 64 nodes. Finally, an output layer. It took 3 minutes to train one epoch. After running it a few times, we just decided to use 2 epochs for efficiency. The final score is around 0.67, and after we doing some preprocessing, we got an improvement to 0.8. The next model is LSTM. Since we are talking about stock data, which is a sequential information, RNN model comes to our mind. It uses the same series of computation for each data item in a sequence. The computation are not only based on the current item, but from previous item as well. Thus, it should fit our problem well. The drawback of regular RNN is that it has a long-term dependency problem. So LSTM was developed. LSTM has an explicit memory structure called cell state that is accessed via gates, like forget gate, input gate, and output gate. These gates determine what data should be forgotten and what should be passed on to the output based on the input and previous state. So before we build our model, we also apply similar preprocessing. We join the news and market dataset and data train test stability with 9:1. Everything is ready, so we started to build our model. After trying different number of layers and units, we found out that a combination of 3 layers with 128, 64, and 32 unit performs the best. For the output layer, we apply a sigmoid activation function. We also apply early stopping and checking point in the model feeding process. When we evaluate our model, we got a score around 0.54. This did not perform as well as we hoped, so we decided to investigate some more. Our initial thought is that the news data might be affecting the result, so we try to apply the model to market data only. It turns out that the results are very similar. We decided to do further research on cargo, and it seems that LSTM is not an optimal model to use, so we decided to move on. Our third model is light GBM. It uses a novel technique of gradient-based one-side sampling to filter out the data instance for finding a split value, and also uses a special algorithm to find a split value for categorical features. The advantages are faster training speed and higher efficiency, lower memory usage, focus on better accuracy result, etc. The architecture looks like this. It's different from the other boosting algorithm. Same as previous model, we apply the preprocessing for the data by joining the news data and market data set and doing a train test split. An additional preprocessing step we also did was feature selection, which let us decide to exclude the data before 2009 due to the burst of the housing bubble and led to the financial crisis. In the feature selection process, we used the baseline model to evaluate the feature importance and choose the top K best features as the final training features. The most important features are asset code and returns open previous market residuals. In this stage, we constructed an ensemble of multiple classifiers and used soft voting to get the final result after getting rid of outliers. Here is the result of our light GBM. The validation score is around 0.53. And after we adding some ensembling method, it goes up to 0.56. And finally, 0.63. Here is the outcome of 3 of our models. And it seems that DNN performs the best. Thank you.